All right, we'll get started. Good afternoon, everyone, and welcome to this briefing on semiconductor supply chains in Northeast Asia, hosted by the US-Asia Institute. For those of you who have attended our other events in the past, welcome back. And for those who are new to the US-Asia Institute, thank you for joining us. My name is Emily Zimmerman, and I'm a program assistant at the US-Asia Institute. For some background, USAI is a nonpartisan United Nations recognized nonprofit with a 40-year track record of building understanding between the people and governments of the United States and Asia. This specific webinar will focus on key areas of interest concerning the geopolitics of semiconductor manufacturing, trade, and policy in Northeast Asia. Since its invention by engineers in the United States in the 1950s, the semiconductor chip has become a focal point of trade relations between the United States and East Asian powers. As demand for high-end semiconductors intensifies in the 21st century, the semiconductor industry has become geopolitically significant in East Asia, and Asian powers such as Japan, South Korea, Taiwan, and China are competing for dominance in the industry. Furthermore, pandemic-induced shortages have already affected the global economy, and potential conflicts in the region would deeply impact supply. Now, I'd like to get the briefing started with just a couple of housekeeping notes. First, I'd like to give special thanks for the support of USAI's corporate stakeholders for helping to make this program possible: the SANS, AIG, ConocoPhillips, and Fairfield Maxwell. I'd also like to note that during the last 15 minutes or so of the briefing, there will be time for questions from the audience. If you have questions that you would like our speakers to address, please type it in the Q&A function at any time, or you can directly message me if you prefer. If you're calling in by phone, you can email usai@usasiainstitute.org with your question. Now moving on to today's program. I'd like to introduce our moderator for the discussion, Donald Morrissey. Don Morrissey is a legislative strategist and consultant with experience in financial services and telecommunications. He has 20 years experience in government affairs, beginning as a legislative strategist for the mutual fund industry through his trade association, the Investment Company Institute. Initially, he served as legislative representative and later as head of legislative affairs. He is currently vice president for government affairs at Huawei Technologies. Don spent 15 years on Capitol Hill, where he helped fund and organize anti-communist counterinsurgency activities in several countries, including Afghanistan. From 1989 to 1955, he helped found and then serve as the first legislative director for the Congressional Task Force on Terrorism and Unconventional Warfare. He also served as leadership staff for the vice chair of the House Republican Conference, Representative Bill McCollum. Prior to serving Rep. McCollum, Don was the communications director of the House Republican Study Committee, the legislative director of the American Conservative Union, and an associate staff member of the House Appropriations Committee under Representative Eldon Rudd. He got his start on the Hill working for Representative Mickey Edwards. Don earned his BA in economics in 1979 from Cornell University. You'll be able to read more about Don in our program found in the chat function. We are very fortunate to have him with us today. So without further ado, I'll pass it over to you, Don, to introduce today's fellow panelists and continue this public briefing.
Thank you, Emily, for that nice introduction. It's always a pleasure to work with USAI. I think it's one of the toughest, smartest, and best small organizations working in and around Capitol Hill and on these policy issues. I've always enjoyed my work experience with them and always been very impressed. I'd like to welcome you all to this standalone briefing on semiconductor supply chains in Northeast Asia. Semiconductors, as you know, are most important technologies underlying all manufacturing and everything we do, breathe, wear, use. From cars to cell phones to computers to clothes to shoes, everything we rely on for our daily lives. The protection of our important information is dependent on the production and commerce of semiconductor chips. We hope this webinar will highlight the importance of these supply chains not only to Asia, but to the whole world and spur further conversation on these issues, particularly on supply chains and both policy regarding those. We hope to give you a better understanding of how the pandemic and the controversy in the region has sparked shutdowns in the supply chain and the impacts on the U.S. and what should or what are outlines are the issues and the policies that may be driven. Before I introduce our guest panelist, Dr. Griffin, I'd like to just throw some facts on the table and just some general facts and maybe some questions. And I am going to quote from our panelist, Dr. Griffin's, some of her work as well. I will also encourage everyone in this audience to go to the Wilson Institute website, particularly just type in Wilson Institute Melissa Griffith, Griffith. Find the article, and she's written a lot, entitled "The U.S. Needs a Sustained, Comprehensive, and Cohesive Semiconductor National Security Effort." This is a group effort. It was part of a, best call it a webinar, but also the conclusions of the panel were put on paper. I think if you're looking at this industry, the policies and the issues, she asked, and the group asked, basic foundational questions that you need to address when looking at these policies, and outlines the state of the industry as well as where possibly things can go. I think it's a must read, and for idiots like myself, it's very readable and understandable. But first, some facts on the ground, and then a couple of questions, and I'll introduce our panelists as USAA asked me to do. If you look at, as a start, if you look at the semiconductor industry as of, say, 2018, 19, or even today, it's a perfect Ricardian model of global supply chain efficiency in many ways. And if you break it down by the value chain or the critical inputs, you look at chip design. The U.S. leads there. That's in the U.S. also leads in distribution and IP and R&D. In electronic design automation, the U.S. and the EU lead. In packaging, China leads. In materials, that's a global effort, but it includes China as well. And for design and equipment, again, the U.S. and the EU lead. To put another way, and if you look at a piece put out by George Calhoun from the Stevens Institute of Technology, you can break down the industry this way. The U.S. dominates in the fabless IC segment. China's position is negligible here. Taiwan dominates in the foundry segment. The manufacturing equipment segment is shared between suppliers based in Japan, Netherlands, and the US. China has a modest but vulnerable position in the low-value IC packaging segment. And again, the raw material supplies is distributed globally. The US right now accounts for about 12% of global semiconductor manufacturing capacity, down from 37% in 1990. The US, South Korea, Taiwan, and China are the top four countries that are dominating the semiconductor industry as of 2022. However, the top customer by far is China, which accounts for over 50% of total consumption of semiconductors. In addition to that, China's semiconductor market is the biggest in the world. Over half, as I said, over half the world's semiconductors go to China. This is because China creates or manufactures 90% of the world's smartphones, 60% of the world's PCs, 65% of the world's smart TVs. To give you an idea of the size of the industry, and again, I'm quoting from George Calhoun from the Stevens Institute of Technology, since 1995, something like 4.5 trillion in global GDP has been directly linked to semiconductor design and production, and another 15 trillion indirectly impacted. In the next 10 years, the industry is expected to invest about 3 trillion in R&D and capital expenditures globally. The auto industry, as you know, is expected to lose about 210, maybe close to 200 billion in car sales due to chip shortages. Intel, TSMC, Samsung, the three top manufacturers in the business, in the fabrication segment, have announced plans to invest 300 billion in new manufacturing facilities over the next several years. That figure is more than the market value of the entire North American auto business. Public funding for semiconductor development can't be fully accounted, but projections indicate that $500 billion in the next 5 years will be spent in terms of public funding. 40% of that expected from media accounts coming from China. Total revenues for the chip industry are now more than 600 billion per year and growing at a rate of 29% year over year in June of 2021. According to the Federal Reserve, the index of semiconductor sales volume has increased by a factor of 33 times since the year 2000 and almost 900 times since 1992. I would also note that and then again, going into talking about Dr. Griffith's contributions in this area. I think one of the things that she highlights, and I don't want to steal any of her presentation away from her, but this is so important. I think she asked basic questions in this paper. I think you all should look at. Why do we care about integrated circuits from the vantage of national security? And she says the answer is twofold. One, their role in supporting critical national security applications, and two, their role in underpinning geopolitically significant technology and critical infrastructure. With that, I'd like to introduce Dr. Griffiths. She is a director of emerging technology and national security and a senior program associate with the Science and Technology and Innovation Program, STIP, at the Woodrow Wilson's International Center for Scholars. She's a non-resident research fellow at the University of California, Berkeley Center for Long-Term Cybersecurity, CLTC, and an adjunct professor at Georgetown Center for Security Studies. She works at the intersection between technology and national security with a specialization in cybersecurity, semiconductors, and 5G networks with a focus on national risk and resilience models. She also heads the Wilson Center's technology labs. Dr. Griffith, please.
Thank you so much, Don, and thank you to USAI and to Emily for having me here today, and to everyone who took some time off on a Friday to talk about semiconductors and semiconductor supply chains, which is important, but also not always everyone's cup of tea. So thank you for all having me and for joining me today. So I think, as sort of Don, you were highlighting, I want to kind of pull us up a little bit and lay out some sort of foundational comments, a little bit of framing around the semiconductor conversation, and then I think we can jump into a more detailed, nuanced discussion from there. And I appreciate your opening remarks, I think laying out a lot of that groundwork, a lot of the statistics. One, so now I don't have to, and two, I think it sort of helps us as we head into this broader conversation. So I kind of want to do four things in my opening remarks. One is sort of hit this conversation that you hinted at there, which is, why are we all here? Why does the United States care? Why do so many countries care about this conversation? I then want to sort of pivot and pull us a little bit further there and sort of say, what does the security availability conversation actually entail? What are we looking at there as sort of problems when we talk about concerns around semiconductor supply chains? Then I'm going to kind of push us into sort of regional dynamics. Why are we talking about East Asia? What's sort of the lay of the land there and the importance of that region in particular to this conversation? And then just a little bit of food for thought, things that maybe we can pick up in conversation or that people on the call maybe want to spend some time thinking really hard about, putting some serious brain power, manpower, woman power on those questions as well. So why do we care about semis? And this is both an economic issue and a national security issue, as sort of you highlighted. And it really goes back to this understanding of semiconductors as geostrategic technology. And that is obviously a loaded buzzword. There are a lot of different geostrategic technologies. You heard several of them in my bio, whether you're talking about AI, 5G, quantum, semis are another of those geostrategic technologies, but they occupy a really unique space in that they are foundational. What do I mean by sort of being foundational technology? They are the foundation upon which software operates and data is processed. This means that they're simultaneously essential for military and defense technology, weaponry and equipment, broader geopolitically significant technologies such as artificial intelligence, these sort of sea change technologies, quantum computing, critical infrastructure questions. If you work in 5G networks, silicon is really essential portions of those conversations as well, to things that you use to drive yourself to work, right? Public transportation and automobiles, or the device you use to make a phone call, how you're sending your emails, your personal computation computers, etc. So it's incredibly pervasive, both in terms of scale and scope, and touches on all of the kind of sources of economic growth, many of those sources of economic growth, and significant sources of economic, military, national security power and projection in that space. So we care about them significantly given that foundational role. And there's a couple buzzwords I will just sort of flag for you there. They create a single point of failure. And that single point of failure means that when you don't have the right kinds of chips, and these are not single chips, you're talking about a diversity of chips in any one device, that device does not go to market, right? That car cannot be sold, that computer cannot be used, the 5G network is non-operable. So thinking about that single point of failure. So that's why we care about them in a general sense. Chips are really important, integrated circuit semiconductors are really important for economic and national security. Great. We could all go home, right? It's really important, but if we didn't have a problem there, there wouldn't be any reason to have a conversation going forward. So what's the problem? You know it's important, something's not going right there, both for the United States, and I think a large number of countries are recognizing that there's sort of need to act here. And there's sort of two buzzwords that I think are worth sort of dissecting: security and then availability of supply when we talk about the semiconductor supply chain. So what do we mean by availability of supply? This is sometimes talked about as resilience, but it means where are vendors located? How many vendors are there in any specific area? What is the production volume for kind of a variety of integrated circuits? And can that production volume meet demand? What are the broader resilience concerns of supply chains? There is a kind of incident in the 90s around very downstream implications, glue, right? If you have a fire in a factory, glue, which is essential to the production of semiconductor chips, they can be held up in that regard as well. So you're looking for choke points, single points of failure, geographic clustering, right? In areas where if you have military conflict or even just environmental issues, take a drought, really incredible weather phenomena, you can lose access to whole portions of these sort of supply chains. So it's about location, diversity, number, and identifying some of those points of failure, making sure you have availability across a wide set of risks or potential downstream bad impacts that you might encounter. That's the availability of supply question. There's also a security of supply question. And this one sometimes gets swallowed a little bit by the availability resilience conversation. And this one's about trusting your vendors and players in the market. It's being able to account for not just the security of the processes, but the security of the players in your own supply chain. And so there's a security conversation as well. And you will notice that those are two interrelated but distinct conversations: secure supply chains, availability of supply, and sometimes the policy solutions actually cut against each other. So thinking about where you're sort of prioritizing, taking each of these in turn, and thinking about the ways in which they're mutually self-supporting or reinforcing, but also very different goals with their very different ways of approaching those goals. So that's kind of the why do we care? What's the problem? You'll notice, and I think the kind of opening comments, Dawn, that you made, that there's some real choke points in the semiconductor supply chain. The one that I think has gotten the most airtime and most concerning is in that production segment. So when you think about a chip, it's R&D, design into production, you have rare earth elements going into that production process, and you also have equipment going into that production process. Then you have packaging and then back out right into use cases. And that production mode is seen as a choke point, with really three foundries in particular occupying most of that space, and really just a handful, kind of one, occupying that most advanced node in that space. And that is a choke point, a real shrinking of the aperture to a very limited set of players. And most of those players are located in the topic of today's conversation, East Asia, right? Taiwan and South Korea, which are geographically clustered and in a somewhat contentious part of the world, and concerns about being that more contentious going forward. So these are those concerns there. I also want to flag that there are completely non-geopolitical concerns at play with security and particularly availability of supply. The pandemic has shown a bright light on supply chains and sort of choke points and concerns about supply chains, and the kind of corresponding shortages in semiconductors, particularly for automobile workers, but more broadly, has been very concerning, but not geopolitically motivated, right? So sort of understanding some of these things can sort of operate separately. The other thing I want to flag here before moving on to why East Asia is there's a long-term and a short-term conversation that needs to happen around availability and security of supply. There's a lot of focus often when we see things like the CHIPS Act coming out of the United States, corresponding acts coming out of the EU and other countries around the world, kind of centering that conversation on current shortages. We need to solve current shortages by building more foundries. Those are 5-year plans, right, in terms of construction and construction costs and setting these up and finding the right kind of ecosystem, the right workforce, and then creating the demand and making sure that kind of feedback is there. But there's also very long-term kind of security, availability, supply conversations that have nothing to do with the current shortages. So sort of putting those in terms of policy brackets and sets of concerns as distinct. So we know why they matter. We know that we care about them in terms of some moments of real concern, both on security, which countries are operating in that space, kind of security best practices, availability around some real choke points in that space, and the kind of loss of capacity and diversity of actors. Short-term, long-term problems. Why East Asia? Why are we having an East Asia conversation? And I think there's a couple different things there that are worth noting. And I'm going to highlight 3. You have the kind of conversation around supply chains and the position in which they occupy. So this is that kind of statistics, Dawn, that you were handing us around leading nodes in manufacturing, and also sort of that East Asia has emerged as the chip manufacturing hub, and particularly the chip manufacturing hub on leading edge nodes. There's also, I think, a conversation that's worth having here, and we should sort of think through together about geopolitical concerns that these countries share. Japan, South Korea, Taiwan have very real stakes in kind of maintaining leadership positions in these spaces, and also bolstering and building into new kind of areas in these spaces as well. And you're seeing those governments invest heavily accordingly. So sort of their geopolitical and their policy moves put them on the map. And lastly, the demand side, Don, which you sort of highlighted as well, which is technological advancements being kind of surging demand for consumer electronic devices, along with this sort of growing market all at the same time, puts demand in East Asia as one of the highest hubs of that demand. So that kind of demand function there as well puts East Asia front and center. I think there's also a series of live questions, and I'd love to end here, that we need to also be concerned about and just have a conversation through. One, which I think you kind of marked, is from a series of countries' perspectives. You have a series of countries that occupy significant positions of strength individually and collectively across this ecosystem. They're looking to maintain those positions of strength and often build into areas that maybe they're lagging a little bit. And then you have up and coming players, and China is one of those significant up and coming players across that stack. And those are really different policy conversations, right? How do you maintain positions of leverage versus how do you gain positions of leverage are very different conversations. So sort of recognizing that. I think additionally, how governments think about intervening in a deeply complex and very global and long supply chain. Apologies, my dog is determined that we're under attack. But how we think about kind of intervening in very complex, globally long supply chains, and doing that in a way that works for industry and for government without undermining your industry perspective. And I think finally, one of the things that I would like to flag is how we prioritize making supply chains more resilient as a national policy without undermining sort of the broader opportunities for cooperation and coordination across countries. So often these are sort of outlined as national sets of initiatives, but it is a very national, international conversation that needs to be happening in one kind of a consortium of countries as well. So I will end on those three, and hopefully we don't have another attack that the dog needs to alert us, a perimeter defense issue, and I welcome the conversation, Don.
Yeah, let me start, maybe a rather convoluted question, and I come from a perspective of a global company that's headquartered in China. We are in a position of being a big consumer of chips, obviously, for our production of 4G, 5G telecom equipment, as well as all the other platforms we have with AI. We're in the mining business, we're in the car business. But we also have, and have had for years, what is typically almost American, a fabless chip company known as High Silicon, okay, for which most of the manufacturing is done by TSMC. We also have a supply chain from the United States, which, barring the export restrictions put in recently by the Trump administration, would be about 22 billion from the United States, of which 60% of that comes in that area of semiconductors. Okay, so it's a very large supply chain to the United States. And then relate this to your last statement about looking at the security of the supply chain and the availability, as well as resilience, but also leaving room for cooperation and interchange. Two questions always come to my mind. If you look at the CHIPS Act, that may or may not be done this month, okay? In essence, if you look at it from a certain perspective, you have the export restrictions put on by the US government, which deprives American chip companies who are leading in design and distribution from overseas profits, which generate their R&D, which helps keep their lead. So that's one hand taketh away, and then the other hand maybe giveth in terms of this new policy with regard to subsidization. My question there is that sustainable in terms of replacing the market virtue cycle, which sustains America's lead, American companies' lead, with subsidy from American taxpayers? Is that, do you think, is that sustainable in the long term? Is it necessary in terms of the questions you addressed about availability, sustainability, and security? I'd just like to get your thoughts on that.
Yeah, I think this question is really going to the root of this these are complex dynamics, right? And industry plays really important roles here. And when you intervene, and I think this, I'm going to sound like a broken record, Don, I know I say this a lot in kind of my work and whenever I'm talking, which is, it is very difficult for government to intervene in complex, technically very complex and industry very complex ecosystems, and to do that effectively without radically disrupting. So I want to recognize the really tricky position government's in that kind of position. Going back to sort of thinking about this ecosystem, I think there's a couple of things that are worth considering. One, I think the CHIPS Act is not a solo venture. talking about much more sort of sustained whole of government efforts much more broadly. So I think often this is the most public facing of those kind of conversations. And if it was this alone, I think we'd have more concern to be worried, but we really don't know what that broader ecosystem is going to look like in terms of support going forward and in terms of intervention going forward. What I would hope that sort of would be on the table is some of these concerns, right? Which is that you do not want to put yourself in a position where the security policies that you put in place, limitations, for example, on acquisitions, on mergers, on where they can sell certain types of products, make those companies unviable within the United States, right? They're not able to innovate or compete. And you're seeing a little bit of that. And I know that sort of there's lines of effort now in place to sort of push conversations about scaling funding, right? In terms of startups up to sort of much larger acquisition type conversations, making sure you fill that gap, which I think are really appropriate, and sort of thinking much more strategically about supporting our domestic industry. I think we also just need to be thinking about what counts as secure in those conversations as well. There's a little bit of, I'm not going to say laziness, but I'm going to say laziness, kind of copy paste America equals secure, and sort of ending the conversation sometimes there. And I think having a broader conversation about what can be secureable, what are good security practices, and what are the range of partners that we need to be concerned about in terms of building that architecture out. And I think the last kind of final comment there, a thing that's also worth considering as we sort of push forward is which portions, which types of companies kind of occupying across the semiconductor space really need to be most concerned about kind of foreign markets and foreign acquisition. And that goes back to sort of important levers in terms of, is this a lever that helps us maintain positions of strength? I'm going to sort of point to equipment manufacturing as one of those important levers versus opportunities for us to bolster and grow into areas we haven't previously been in before. Those are really different policy requirements if you're talking about trying to take something off the table versus compete in an area where there's many other options on the table. So it would be a blunt force instrument if we applied that logic very, very widely across the semiconductor supply chain.
That's important. And my second question would be, it relates to that, is sort of the other side of the coin. If you look, you discussed the supply chain security and where the choke points are, and where not just the United States, but different countries have to assure themselves of both availability and security on the supply chain. But it's an irrefutable fact that China, and I'm not talking about the business Huawei is, I'm talking about overall manufacturing. The statistics I released, China consumes over 50% of the global production of semiconductors. That is not aimed at semiconductors, it is based on their broad manufacturing base. So my question becomes, if you do that, but you also have policies about restrictions or embargoes or trade restrictions, the question that comes also to my mind is, down the road, if you build up or strengthen or affect different parts of the supply chain, then the question comes to me, with those restrictions in place, who are you going to sell the chips to, unless you have a broader manufacturing policy too? Because again, these chips are not standalone like a cup that you buy. It is part of somebody else's supply chain, every chip, okay? So I'm wondering, I don't think enough attention has been paid to that. I don't think that's necessarily your purview, but it begs the question, where are you going to sell the chips? If you have changed your view and changed supply chain, if you have restrictions on export, where are you going to sell those chips? And we know this industry, as I was trained as an economist, it's very inelastic in supply and demand in the short term. It's not in weeks and months. The supply is very inelastic. Over years, it's not. And so I'll get your comments on that if I could as well.
Yeah, I'll offer a few comments, and then I'm going to throw a few more things that are maybe worth consideration in that same bucket. So when we're thinking about, yes, very inelastic, this is not an industry well known responding quickly to shocks, and it's given that kind of trajectory, right? Also demand and sort of holding births and being able to do that design all the way through is not an overnight process. So being able to meet really sudden changes in demand or radical changes on the supply side, it's not particularly elastic. I think that's a good point to sort of highlight. I think I'd highlight a couple other things as we think that through. Some of these are long-term, short-term problems. I think it's important to recognize that, right? When we're talking about providing ourselves with a window of opportunity by limiting access to certain very clear leverage technologies, I'm going to sort of point to equipment manufacturing as one of those. That's not a long-term solution, it's a short-term solution. And so thinking through some of those long-term impacts relevant to a short-term solution, that's not going to long-term in 20 years prevent China, for example, from becoming a much stronger player in the semiconductor space. It gives us a window of opportunity to limit that growth and then build out on our own strengths and our own opportunities in that space. So thinking about the long-term, short-term kind of challenge. The demand side, I think I would add a couple other pieces. Yes, I think demand for chips is incredibly global and very centered on East Asia at the moment. That doesn't mean that all chips are the same. Incredible surging demand in the United States for AI application chips, right? And a diversity of very specific use case oriented chips. That's a heavy market globally, but also a surging market in the United States and an important market in the United States. And much more broadly, I think the United States is going to, and I hope other countries will join us in this, be strategic in how we understand our strategy here. So I know there's been some conversation about America alone. That is not how I see our current policy, and I hope it will not become our policy, both in terms of the kind of demand we're looking to satisfy and the types of markets we're looking to foster. So similarly, I don't think China can supply all of their own chips for all of their own domestic market without any external involvement there and be competitive and innovative at scale. So they're going to face the same challenge we are long term. They're going to be selling to a global market.
Yeah,
I think that kind of challenge cuts both ways.
I think the figure, and I may be wrong, I think China satisfies only about 12% of its own internal use, and it imported something like almost $400 billion worth of chips in the last year. So yeah, and even though it's the largest consumer, its indigenous China's indigenous needs aren't being met by a factor of about 5 or 6 in that regard. So I think you got to a point there. So the question comes. So let me ask this question. If you look at, let's say, 2019, 2018, you had, as someone that's characterized, was actually Roger Entner at Recon Analytics, a perfect Ricardian model of global supply chain. Was that broken? Or is it both from a supply chain, purely economic, supply chain perspective, and then a national security perspective? Was that broken?
So I don't know if it was necessarily broken versus, so I'm going to take a slightly different tact. I think we're in a different moment. So it is very difficult, I think, for the supply chain, and I'm going to be kind of clear about this, current shortages. I'll take this as an example around sort of a couple different factors where at play there, right? One was COVID-19, a really kind of surging, but also interesting kind of drops in demand. Also particular customers really cutting back on what they were basically holding in manufacturing facilities for their orders, and then hoping to scale back up very suddenly and be able to do that at scale without recognizing that that portion would be filled with other customers, and it would not be quite that easy to sort of rescale back up in that space. And some of those customers not being as experienced with navigating the semiconductor supply chain as perhaps others. So you had this kind of radical changes in consumption at the same time as sort of real drops in what the demand was looking like from some of the key customers, not holding a certain amount of kind of percentage of basically capacity in some of these fabs, and then trying to scale back up very quickly when that kind of scale up was starting to happen. And that is not how that works in a very technical, that's a technical way of saying that's not how that works. And that created some pretty long lasting shortages in that space. Is that a failure of the semiconductor supply chain? I mean, you can't be resilient against everything at all costs, right? So there are always going to be incidences where we get a perfect storm and there will be shortages, regardless of what we do and plan. We have to decide how much we're willing to invest and how much cost we're willing to incur in those spaces, and asking the industry to incur very significant cost in a way that does not change their resiliency picture, but would change like a global or national security picture. That's the job of policy to try to square that.
Right. That was my next question in terms of looking at the same question, but just from a national security point of view. Is it broken, or, and then I guess my major question, and again, I would encourage everyone to go to your name, Melissa Griffith, at the Wilson Center to read this article. It's a very good primer, more than a primer. The U.S. needs a sustained, comprehensive, and cohesive semiconductor national security effort. Okay, so the question becomes: you have the CHIPS Act, which has several parts to it, but the largest part is essentially subsidy and also looking at fabrication. Okay, specifically in the United States. When that is accomplished, what do you think is next, both from an economic but then from a national security point of view, and how would you craft that to meet your test that you stated earlier which is to protect the availability and the security of the supply chain, but also to keep cooperation and meaning trade open in terms of both supply chain and sales. What do you think is next, or what are the, maybe not next, because I'm not going to ask you to write a specific piece of legislation policy, but what are the things that should be looked at for this audience in terms of policy?
So I think there's a couple. So one is the international dynamic, which I think we've heard in a lot of conversations, a lot of bilateral, multilateral agreements. Semiconductors is often one of the top 4 things when their technology policy is on the agenda. But having a much more nuanced and systemic conversation about how to stay out of each other's way. So there's a huge amount of sort of countries trying to invest in a very similar space. Unclear if market demand would support, right, that kind of radical addition on supply, or if we would necessarily get a bubble at some point where demand comes back down at some point. So sort of trying to think through those, trying to occupy similar stages of the life cycle. So I'd love to see a lot more on the international cooperation conversation and the kind of deals, and I use that in a kind of loose sense, but the kind of deals and opportunities we have to work with some of our core allied countries in this space to start occupying positions of strength collectively. So I would love to see that. And I think you're starting to see that conversation shift just in our buzzwords, right? There was sort of onshoring was a big buzzword, and I'm starting to hear a lot more ally shoring or near shoring. So that kind of conversation puts us in a little bit more of a diversity sort of landscape. I think another thing that I really think the conversation needs to move to, and this is not a criticism, it's more just states of maturity, is starting to chase some of the second and third order questions that are at play here, right? And this is sort of like what counts as a secure vendor. These are those mergers, acquisition kind of questions that you've sort of hinted at, but also much more broadly, not talking about chips as a monolith. And this is some of the works we're starting to do at the Wilson Center. What are the chips that we need in 5G, particularly when we're thinking about radio access networks? And the differences between proprietary integrated conversations and Open RAN conversations in that space, and the hardware conversation that should happen. What are the chips conversations around AI, the chips of yesterday, today, and tomorrow? And how are we remaining competitive and innovative and securing those supply chains and making sure we have availability of supply in that space, given sort of the national security imperatives and economic imperatives around AI innovation? How do we sort of think about our chip space around space-based architecture, right? These are chips that are incredibly niche. The communities that sort of build them are incredibly niche, not huge market potential, and yet are now in an increasingly contested space, occupying an increasingly important part of critical infrastructure, and have incredible robustness costs because they're operating in space. So what are the sort of security of supply, availability of supply conversations for space-based critical infrastructure around chips? So to me, it's both kind of broadening the aperture internationally to have much more systemic dialogues with countries about winning, losing deals, not getting each other's way, because I think that will only undermine sort of our space there. And then similarly in the United States, chasing chips in particular and their particular supply chains, their choke points, their single points of failure, and the security and availability concerns for each of those. They're shared in some senses, and then others are completely different sets of concerns. So I would sort of focus on dissecting in both of those spaces, getting a little bit more granular.
On the national security area, particularly space or direct national security implications, e.g. weapon systems, something like that, can you solve that problem simply with each country having trusted boundaries in that area?
So this has been a conversation for a while, I think, like potentially, but think about sort of the use cases for a lot of those chips that you're talking about. Often they're not leading edge nodes. You're talking about legacy systems and sort of maintaining access to legacy based chips. And there's a whole way of sort of conversation about those as well, and sort of ways of introducing those. And sort of thinking about kind of trusted foundries much more broadly, you still need to have a business model that supports those foundries, and increasingly government is not it. So we used to talk a lot about spin on, spin off, and a lot of these solutions would spin out of government. The big commercial case would happen in government, and then you could sort of expand out much more broadly. And now government, and particularly DoD, is a smaller and smaller portion of the kind of economic case for those companies. So they still need to be viable much more broadly and be able to compete much more broadly, because the government as a customer is not a long-term innovative, economically viable plan for a lot of those foundries.
Right. I think a lot of times the issues on supply chain and stuff are put in the context of China, US. But if you look in the comments you made about East Asia, if you look at the lead, in sectors in this area between South Korea and Japan, and again, I'm not an expert on this, but you basically have South Korea's had leaders in DRAM, production. Japan's a key player in the equipment and chemicals, but there are tensions between Japan and South Korea. Likewise, TSMC has a significant market share of all semiconductors in terms of fabrication, based in Taiwan, despite the fact that, as we've discussed earlier, TSMC is building a plant in Arizona right now, and Intel is building 2 plants in Ohio, or announced them recently. What are the tensions just regionally in East Asia? How did that play into the questions you addressed, both of availability and supply and actual national security issues on an actual supply?
Yeah, and here I'd love to take an opportunity to plug the work of one of my colleagues at the Wilson Center, Shihoka Goto, who's with our Asia Institute, who focuses very specifically on the sort of geopolitics, geoeconomics dynamics between a lot of these countries, and has actually worked on semiconductor supply chains in that context. So I would love to sort of flag, I think, some of her expertise there. And I think one of the things that kind of comes up from that conversation, and I'll sort of do an injustice to her work and then sort of pivot you all to kind of read some of her work. I think there's a couple things that sort of rise up there. There is a shared concern. It starts with C and ends with A, right? China, regionally between a lot of the countries that we're sort of talking about, and a kind of geopolitical set of tensions that have arisen over that. And then there are very real kind of geopolitical tensions between the countries and competitions between the countries as it comes to industry. And importantly, they don't always occupy the same portions of those stack, but they're looking to build into similar portions of that stack. That is the same kind of conversation actually historically that the United States and Japan have had, right? We think about our relationship with Japan on semiconductors not that long ago was incredibly contentious. And there's a lot of concern about sort of the space that Japan occupied in this area and in other areas much more broadly, and being seen as a tech leader and kind of a direct line or a potential threat for US innovation or competitiveness in that space. And now we're talking about them much more as an ally with a very clear sort of external set of concerns. But I think what this sort of goes to show is that countries have domestic sets of concerns that are technology-based and otherwise. They have core industry concerns, technology-based or otherwise. And that is exactly the policy moment that we're in, right? We have a general agreement that we want more secure and resilient semiconductor supply chains. There is a set shared geopolitical set of concerns as well, but the ways in which we actually operationalize that are very much up in the air. And those will not be determined just by geopolitics. They're going to have to be about industry deals and deals in a much more nuanced manner than we've certainly been discussing.
Okay, this may be a little, I wouldn't say arcane, I'm trying to get this correct, but if we talked earlier about the production of semiconductors in China, and the size of it as it meets its indigenous needs for across the board manufacturing. A significant part of production there in China on semiconductors is done by foreign firms like Samsung in terms of fabrication, and they're located in mainland China. So how does that affect the tensions? Samsung's originally a Korean company. How does that affect the tensions in that region, or where does that fit into policy? I think the question I would have. I mean, is that a concern?
Yeah, I mean, I think locations of fabs are always a concern for a couple different reasons, right? One, there's always sort of a proliferation concern around best practices, technology, workforce, access to intellectual property, et cetera, that always exists when firms sort of move much more broadly. But I'll give you the kind of US example of this. And I think you can read the inverse of sort of the China concern. So one of the things you're seeing from these same companies, Samsung, TSMC, right, for example, are opening and kind of committing to opening foundries in the United States. That has a couple different sets of great externalities for the United States. One, we don't have necessarily the workforce currently built up at scale to support production that we're sort of talking about here. Workforce is broad. We have workforce that's incredible in many other areas. This is one we would need to be actively building by sort of having countries commit, leading edge countries commit to coming over here and building out expertise. We have a really great education externality there, right? Opportunities to build up workforce through experience, through sort of these different foundries as they come. That is going to be the same conversation in other countries as you open these foundries. Opportunities to learn, to provide different types of restrictions, right? These are some of the kind of conversations around sharing and intellectual property, right? All those things are happening in the United States. And then similarly, building up a wonderful ecosystem around those in terms of customer bases, environmental policies, and that kind of cyclical ecosystems that you see start to emerge around different fabs. Those are all the conversations that are happening in China as well. So I think kind of thinking about all the reasons we want fabs here are very similar reasons to why they would want fabs there. The degree to which, and this is where that security availability conversation runs into each other, the degree to which you want to diversify your locations as much as possible versus eliminate locations as much as possible. One of those is a security concern and one of those is an availability of supply concern. And they can kind of run up against each other in really meaningful ways. But part of that's a business practice question. To what degrees does Samsung guarantee security of product in those environments? And sort of availability of the supply coming out of those factories. That's a Samsung question. It's a TSMC question. It's an Intel question. It's an Infineon question.
Oh, that's good. Well, then let me ask another question. Unintended consequences of policy. If you look at, and again, I'm mostly going off media reports. If you look at announcements in the media, specifically related to China, you've heard the phrase China 2025, specific efforts looking at the full length of supply chain in terms of building up the Chinese chip industry. My own company, as you said, as I've said, has had, like many US companies, a fabless chip company called HiSilicon. It was in the media recently that there might be a negotiation with Huawei in terms of going to a foundry. I don't think that decision would have been made, or if it's made, regarding going into the actual foundry business, except nonetheless because of the export restrictions put on by the United States. Are there unintended consequences from some of these policies, looking at, real security, real availability from different countries' perspective, okay, that you may have unintended consequences in terms of accelerating further changes in the supply system in terms of geographic location?
Yeah, always. And there's unintended consequences and there's rebound effects, right, as well. And we've sort of hit at the start of this conversation some rebound effects in some of the questions you spoke to, which is in your attempts to navigate, constrain, curtail certain countries' efforts in the space, you may curtail and constrain your own company's efforts in this space, right, around kind of market forces. So that's kind of rebound effects to some of these policies, and you want to try to mitigate that as much as possible. And then you have unintended consequences. And I think this is actually sort of, to me, a little bit about that time and temporality question here. So it's, what do you think you get the biggest bang on your buck for and when? So if we are able to get a short-term slowing down around Chinese development in this space, will we be able to capitalize it on enough that the long-term future that you're hinting to would happen or otherwise would not happen? Maybe. It's an open debate. It's clearly the gamble, right? Which is, if we can place enough kind of levers of power now, we're buying ourselves time to sort of solidify our own policies. The degree to which we're coming out quickly enough and sustained enough and comprehensive enough, both in the United States and across countries, to do that, unclear. But that would be, to me, the more unintended consequence conversation, which is just not calibrating that window of opportunity correctly. I think the other sort of portion here, which we're dancing around, I think is important to say, is that the world in which we deem success cannot be no China in semiconductor supply chains, right? That's not a feasible conversation, just given the role of China, the kind of ambitions of China, the ambitions of the United States, the role of the countries in East Asia that we've sort of outlined that are not China. Countries will occupy different portions of these supply chains. The question is, can we get that mix good enough that we're comfortable enough that we can kind of manage some of those security and resiliency concerns? It won't be 100% for US policy. And I think for Japanese policy, for Korean policy, for Taiwanese policy,
okay.
it's managing those risks.
Okay. And I go back to your remark earlier, you were looking at, how do you look at a broad, and I think you used the phrase allied, effort in terms of looking at supply chain. So I could take, for example, what you said is, you don't think the US policy should be a complete US-based vertical integration of the industry.
No, and I think that's for a couple of reasons. One, I think it would be a waste of our money and our political effort, given that we compete across a wide variety of technologies. We are geostrategic technologies, not a geostrategic technology. And two, one of the reasons we care about semiconductors is about the incredible innovation and what they enable. If we radically hamstring that industry, a lot of the reasons we care about the industry start to suffer as well. So AI innovation would be an example of that, right? Where we want to be able to have leading edge, constantly pushing the aperture, incredibly innovative solutions in that space. And when you start pulling apart a very global, very complex supply chain into very siloed pieces without that kind of feedback across that supply chain, you really curtail innovation. So to me, it's about making sure you maintain enough of that innovation that we get the benefits from semiconductors that are the reasons we care in the first place, and then kind of managing those risks just enough in the ways in which we restructure current supply chains and manage security and resiliency across those supply chains, that we are able to feel like we can absorb that risk in the long term, not to completely eliminate it, but make it manageable. And that's both a national question and an international question.
Okay. Just as a sidebar note, we got a question saying, would you be able to mention the websites to read the articles mentioned in the briefing? I would point to, and I will send links to the USAI staff, but I especially, again, would highlight Dr. Griffin's article, particularly on her website. If you just type in Melissa K. Griffith and Wilson Institute, you will find her list of publications, and the article that I think is most critical, but it's also, you can also watch some of the article because it's a summation of essentially a webinar, is called The U.S. Needs a Sustained, Comprehensive, and Cohesive Semiconductor National Security Effort. It is at the Wilson Center website. Type in Melanie Griffith and Wilson Center, and you'll go right to her and her page on the Wilson Center and her publications. And I think that's an excellent article. There are also some good articles, which I will send to the USAI people, USAI staff, they can disseminate to you, both some analysis on the larger issue of decoupling from Roger Entner at Recon Analytics, as well as some writings in Forbes magazine by George Calhoun at Stevens Institute of Technology, which I think are very good primers on this policy, and we'll get those to you. But I would recommend this key article because it lays out all these issues with regard to what is the situation and what are the broad outline policy prescriptions. Haven't got to proscriptions yet, but I'm trying to get there. But I think that's where it can work. So at an end state, I mean, when you look at, and just from my company's perspective, we're a big consumer of chips. We're the largest manufacturer of telecom vendor. We have 30 globally. We have 20% of the 5G patents globally. We're also a producer, again, a fabless producer of silicon chips for our own consumption, not for others' consumption at this point. Where do you see that? Where do you see that going? And I don't base this just in the U.S.-China geostrategic positioning, but is there, and for our audience perspective, is there inside the technology of chips, can you delineate where it is important? You know, can you say, well, above 5 nanometer, it doesn't matter where the chips come, or below 5 nanometer? Obviously, as we talked earlier, there are special cases for direct military and national security perspective, which you may want to look at a trusted founding. But can you say at the end process, you know, there's a level there which it doesn't really matter? And again, that's a continually evolving process too, as it's
continually evolving. So I think there's certain use cases. So I'm going to go to use cases versus type of chip and node, because I think that's actually for me where this conversation, the rubber meets the road, which is like what portion of chip manufacturing, which types of chips does the United States need to have incredibly resilient and available supply chains and incredibly secure supply chains for. And the kind of military intelligence applications is one of those, but that is a pretty small kind of subset. I wouldn't necessarily, as we talk about use cases, so for example, ASICs, right? And that's sort of thinking about AI basic. There's a whole variety of chips that are emerging in the AI space. ASICs just one of them. There's a conversation there about how important the availability and the innovation of those are, and for us to be leading in that space.
Well,
that's one example, but it doesn't have to be all, right? And same with legacy. Go ahead.
Yeah. Let me interrupt on AI. When you get at a very, I wouldn't say shallow, but the first level reading on AI in terms of development, an interesting article I read once said that China had a natural lead on AI because AI feeds on data, and the data availability of the domestic population in China hugely outshines any other country. Okay, is the weight of that data and the availability outweigh the processing?
So there's three things, right? For anyone on this call who's like, wait a minute, what? Artificial intelligence is often thought about as a stool. There's sort of three legs to that stool. A senior person in government once said there's also a really important floor. This is true, which is workforce and talent, which we often don't talk about. But of the three portions of that stool, you have algorithms, you you have data, and you have computational power, compute. And compute is, those are chips. There's been a whole conversation and some, I think, influential books about the types of data that China has access to and the scale of that data. I think this is a sort of conversation for a different day. I'll give you a little bit of a preview on some of my thoughts there, but amount of data is not the only thing that matters, right? Quality of data is another really important piece. And we're getting a lot of really interesting kind of conversations also about synthetic data. So I think that kind of just sheer numbers is not always our best metric on that kind of one leg of the stool. And when we think about the importance of compute, this is, I think, one of the least recognized in the AI community, where we talk about algorithms. If you were sort of thinking about the RSAs of the early 90s, algorithms were sort of, you couldn't share them, right? They were somehow like weapons technology. They were classified. You shouldn't be able to share them or export them. So there's been whole conversations about competing there, a lot less on the compute side. And there's some real innovations in the compute space that can let you do some really unique things, getting around some real data limitations, for example. So there's a big lift that's happening there in incredible ways, and a real interesting cyclical sort of movement that's happening in the semiconductor space, where use cases are increasingly creating very specific design and kind of production processes for those chips versus much more general purpose and their utility. So I think there's a lot of movement there, but I don't think it's as simple as who has the most data, therefore shall win on AI. And the chip space is incredibly important in maintaining AI innovation going forward, and also being able to sort of overcome some concerns on data, not just sheer amount, but the kind of data that you don't want kind of gathered about you, right? Personal data, healthcare data, for example, and importance there. So the chip space would be an important place to remain competitive. Does every AI chip need to be made in the United States? No. Right, so sort of thinking those things through. One's about maintaining a competitive, innovative edge, so there's alternatives. And the other is much more about saying, in this one space, we need a particularly secure chip that is incredibly available, which means a lot of redundancy built into that supply chain at high cost. And in others, we're sort of saying, we need really good access to legacy-based chips, which we are not talking much about in this conversation, but are just as essential to a lot of the kind of general technology most of our listeners are using every day. It's not a leading edge node chip. In isolation, there are a lot of legacy chips in those devices as well that you would lose access if you lost those too. That's an important point, I think, too. Yeah, legacy chips. That's very good. I would emphasize for everyone on this audience again, Melissa K. Griffith at Wilson Institute, that page, and we'll forward some direct links to the USAI staff for you all to read. Let me ask one last question, if I might. What is the worst thing the United States can do in the next 2 or 3 years as regards chip policy? Good clarification. What's the worst thing the U.S. could do? It's like, oh, that's a big question as in regards to chip policy. Yeah, so. Well, let me qualify it and generally preserve what we perceive as the relatively ease of flow of goods and services in international trade right now. So I think there's two things. I think the sort of question you framed it the first time, what immediately popped into my head is not playing the long game. So you'll sometimes, because there are so many technologies of concern right now for the United States, there will be a sustained effort on a really important foundation, right? So an assessment of the supply chain, some really important initial interventions, and then the next important technology sort of swamps it, the technology conversation. And this is a long game, not a short game. And it requires both sustained investment, sustained commitment, and also sustained commitment to going into the weeds on a lot of these conversations, as we've sort of been talking about. And that's the next step. So if it's a little too episodic, we address it when it's very heightened and there's a big shortage and everybody's kind of willing to have that conversation, then we don't continue to address it over 2 years in a nuanced way. That would be an incredible mistake because other countries are. So I'd put that out there. I think the other mistake, which I am glad to say that we are more nuanced in the current moment, and I hope we continue to be, is to assume that security and availability are the same thing and both are synonyms for America. I think would be the other incredible mistake. So those would be my two. Thank you very much. On that point, thank you. You've packed a lot in an hour. Really appreciate it. Very, very stimulating to talk to you in terms of getting some of the answers. And again, I would encourage everyone, we will send direct links to the USAI staff, but the webinar and the summation of that webinar in written form at the Wilson Center website is an excellent look at what are the baseline questions that policymakers need to address going forward. I would add a baseline question, again, as I said earlier, is
when you set up these supply chains to your satisfaction, where is the market? And I think that's an important question to also ask on that. Emily, thank you very much. All of you, I don't see any other questions. The main question I saw was the availability of those websites, and we'll forward some of that data to you that you can forward to the participants. And thank you very much. And Dr. Griffith, thank you very much.
Thank you for having me.
Thank you both. Dawn, I greatly appreciate you stepping in to moderate today, giving both your perspective and leading our discussion today. It was both impressive and fascinating to listen to. I'd also like to give a huge thank you to Dr. Griffith for joining us and providing her excellent insight. We were honored to host you, and we appreciate the time you've taken out of your busy schedule to deliver your valuable perspective. And though we are out of time, we present the opportunity for those tuning in with interest in U.S.-Asia relations to reach out to the U.S.-Asia Institute. They have questions relevant to our future events. If anyone in the audience would like to follow up with any of our speakers, please reach out to us at usai@usasiainstitute.org. We'd be happy to assist in fostering further dialogue on the issues we discussed today. Thank you again, and I hope everyone has a great rest of their day.
Have a great rainy weekend here in DC.
Thank you, guys.
All right, see you later.